Okay, so this is 2019 RC, and this was an object that was on the NeoCP list and has just now recently been confirmed and has received a new designation. So anyway, the point of this video is to kind of walk through some of the new features that you can expect to see in the upcoming version of Tycho, which will be released shortly, and also to point out how you might go about solving or generating observations of an object of this nature. So to start with, we have the image manager, and I have loaded 85 images into the software. And what we want to do at this point is learn more about the object. So we can go to Tools, Download Observations, and in this box here you can see where you would type in the name of the object. Again, originally it was on the NeoCP list and it had this designation, and if it were still on the list, we go ahead and click OK. But as you can see, it's no longer there. No observations were returned. So instead, we have to specify the new designation of the object. And if you are not sure what that is, you can always go to this link here, confirmed object page, and type in the old name of the object. As you can see, the association here is 2019 RC has been assigned to the object. So in any case, we will go ahead and retrieve the observations as it's a confirmed object from the observation database. And what we can do with this is we can attach ephemeris to the data set. And what this does is it invokes the find orb software, which has been slightly modified for this purpose. And with this button here, we can return ephemeris. And as you can see, the columns now have been populated such that we are able to determine whether or not the object is in the field of view for each image. And so if it were not, we could exclude those images from the data set. And we can also determine the speed and positioning of the object for each image, which makes more is more of an impact when, say, for example, you've done a half an hour or so on a very fast object that's changing in motion over time. As you can see, this is 3.18 arcseconds per minute starting out to, and it then decreased to 3.14. So there are slight change in speed, not too much, but in any case, at this point in time, we can go ahead and run the tracker. Now again, none of this is really required, but it does make things slightly more convenient. So let's go ahead and run the tracker on this object. And so these first few steps here, I've already talked about in more detail in other videos and tutorials, but auto threshold, we're just going to go ahead and set that as the mask. So this is a slightly, well, actually a very crowded star field. And so let's go ahead and click OK here. And I like to run this sensitivity threshold by default for known objects. It almost always works. So what's different here is that we can click this button, use dataset ephemeris. And so it's going to go ahead and specify the limits on speed and position angle for the search based on what we imported here. So lower and upper bounds on speed and position angle. So 494 motion vectors, we can go ahead and click OK. And as you can see, the software is already processing it. And it's not going to take 17 minutes. That would be the case if we had a wide open search space, but this is again a known object, so it won't take nearly that long. But it will take some time, so let's go ahead and give it a moment to process. Okay, it looks like it's finishing up here, and so shortly we'll have the results. Okay, so as you can see, this first track is indeed quite promising. So, and if you are not sure, you can look at quality column, and usually anytime you have a noticeable difference in quality from one track to the next, especially the first few, 28 is huge compared to all these others are stuck around 10 and then 9 and so forth. So, and you can also look at this window here, and it certainly stands out as an object. So in any case, we're going to try that. So we're going to load the star catalog, and it will allow us to create observations. So we can go ahead and optimize track here, and then verify the track. So what you're looking at here, again, this is a very crowded star field. So all of this interference here is from the stars in the image, and so we can switch over to this view here, and that will help to some degree to kind of show what we're looking at. Again, not terribly helpful in this animation, but bear with me. We could also look at just median combine, and maybe that helps somewhat as well, but still kind of hard to tell what it is we're looking at from just this. So let's go ahead and create the observations. Again, this is 2019 RC, and we have generated them here. So if I click on the first observation, then it will pause the animation, and you can see more clearly what we're looking at. So I'm going to go again back to this view here. So that stands out as a detection, and so does the second stack here, and finally the third observation. So again, much better confidence that this is in fact the object of interest, and so median combine, we can again look at that. So that's what it looks like in the median. So anyhow, if we're on the average combine, what most people would tend to use, as you can see, there'd be no hope for measuring the object. There's simply way too much star interference. So this is kind of cool that we can actually do this in the first place. So now the big question is whether or not the new version of Tycho, again, I've made some improvements with centroiding algorithm and other facets of it. So these are the original observations taken with an earlier version. So let's go ahead and just see what that looks like with those original observations. And so we had a 1.1, which is not great, but it's acceptable as far as that is concerned. So then did we fare any better with these newly generated observations? So I'm going to compare that here. So the new observations, it looks like a 0.46 is the max residual. So that's definitely improved in that aspect. Of course, this is only one data set, this is only one object, so you'd have to do this if you wanted to construct some kind of histogram of performance. And I'm actually doing that, so I will have a more thorough analysis of the improvement that has been made. But in any case, this is quite good for such a crowded star field, and so and this is fairly straightforward to extract the object and generate observations. So thanks for watching, and I will see you next time.